to BKW Physics. I'm Mr. McConley, and we've been doing vector problems, and specifically we've been doing vector problems where the two vectors meet at 90 degrees. Well, this problem is the next step in the process. This problem, if you look at my picture here, you can see that I have a post that's hanging a sign that says sign. And the sign weighs 168 newtons. And it's held up by two cables, and these two cables are the same length, each of them being the exact same length, and they meet the sign at an angle of 22.5 degrees. That's the angle between the cable and the sign. Now, you can see that these don't meet at 90 degrees, so your old techniques are kind of out the window at first. Until I show you that you can adapt your old techniques to solve this problem also. So just to be clear, let's label these so you can tell them apart. I'm going to call this one B, vector B, and this is going to be vector A. And if they're vectors, they have to have a direction. They have to have an arrowhead on them. And in this case, since the sign is pulling down, which way would the arrowheads be pointing on these cables? Show with your hands. How would these arrowheads be pointing on these cables if the sign is pulling down? Yeah, I'm seeing a lot of people doing it, and so you can add that to your picture now. You can add that the arrowheads would actually be pointing down and inward towards the sign because that sign is yanking down on those cables. And what I want to know is how much tension, sneaky word for force, is on each cable. How much tension is on each cable? So there's 168 newtons pulling down, and the answer is not going to be 168. And it's not going to be half of 168, it's going to be something different. So how do we go about this? Well, first of all, our picture is not set up correctly to add vectors, because we know when we add vectors, they have to be tip to, thank you, tip to tail. So I'm going to take this picture and I'm going to adapt it or redraw it over here. So I'm going to draw A, and I'm going to draw A the same length as it is in that picture and pointing in the same direction as it is in that picture. But this time I'm going to take B and I'm going to attach B to the end of A. So B would look something like that. So I got the first A, tip, connected to the second B, tail, and I have, now they're connected. So where does my resultant fall on this picture now that I've moved some things around? From where you to where you, okay, from where you start to where you end. So my resultant is going to be right there, the one I just drew in red. All right. That being said, it still doesn't look like anything's at 90 degrees, so how do I fix this problem, or how do I make it so I can actually solve it? And it's a really easy step. What you do is you take this and you split it right in half, so that this dotted blue line that I just drew meets at 90 degrees to the resultant and splits this in half. Now if you go back to your original picture, look at this triangle right here that I'm outlining here. This triangle here. Look at that triangle and compare it to this triangle. And you notice that they're the same triangle.
Sorry for the interruption.
So what I'm saying
signed up for sports physicals, please report to the nurse's office.
is this angle right here is 22.5. Because see how it matches that picture? And at that point, what can I do? Well, let me erase this R for a second. If I know this angle, and I know that the whole resultant, the red resultant, the whole resultant is how heavy? What weight? 168. Then how much is half of it going to be? How much is half of that going to be? You following along? It's going to be 83. Oh yeah, 84, because that's 168. So it's going to be 84. So this little piece right here is going to be 84 newtons. And this little piece right here is going to be 84 newtons, because they're each half of the resultant. And that puts me in a perfect spot to finish this problem off. Because I'm looking for how big A is. And now I have a little right triangle. So let's finish it up. Opposite over hypotenuse. That's which one? Which trig thing? Opposite sine, right. So sine of theta, I always start by writing my equation with no numbers in it, is the opposite over the hypotenuse. Sine of 22.5 degrees is equal to 84 newtons over the letter vector A. I'm trying to solve for vector A, and when I do a little magic on my calculator, it comes out to be 219 newtons. Check that for yourself, but you can trust me. That's what it turns out to be. So A is actually 219 newtons, which is exactly what this question was asking. How much force is on each cable? This cable right here will have 219 newtons, and this cable right here will have 219 newtons. And a lot of you are saying, how is that possible? Because the sine only weighs 168, and each of the cables is getting 219. But I just want you to think about this. If you hang from something and you hold yourself like this, and you weigh 200 pounds, and each of your arms is going to have a stress of 100 pounds. But as you try to hold yourself out like this, which is called an iron cross in gymnastics, how much stress is on each hand now if you weigh 200 pounds? Much, much more than 100 each. In fact, each arm is going to have to hold more than your own body weight. We'll come back to that topic later. For today, physics.